Hello students, today I discuss about the maxima and minima. Maxima and minima in differential calculus. So here we discuss how to find out maxima minima of a curve. Just look this diagram. This is the coordinates in 2 dimension, x, y. This is 0. So we are taking a curve in this way. This is y is equal to fx. So here we are getting these points. This is we are taking this is x1, this is fx1. This is also a maximum for a curve, for this curve. This is a minima for x2. We can write down fx2. So we have many maxima minima in a curve. So how we can find out this maxima and minima, and at which point this this curve takes maximum or minimum values or extremum values. So we have condition. If we look this, that for this point here we can direct look this, the tangent becomes 0. The tangent at extremum points or maximum or minimum points, extremum points become 0. So you can directly say that if first derivative of ax is equal to 0 for extremums, for all extremums. So this is a condition that for any maxima or minima, the tangent must be equal to 0. Or we can find out this in this way also, that we can take a neighborhood point like this x1 plus h will get this curve of this fx1 plus h, fx1 plus h. So maximum or minima for both, you will get that fx1 plus h minus fx1 less than 0, since at maxima fx1 plus h must be less than fx1, and if we take negative of h, fx1 minus h, this will be also less than 0. So if we take fx1 plus h minus fx1 by h dividing by its 0, it will be nearly tending to 0. If we take the limit value where h tends to 0 plus minus, means from both sides, so this limiting value will be nearly 0. So we will get the same condition that first derivative of ax at the point x1 must be equal to 0. So this is the required condition for extremums. Now we will check out how we can understand where the point at any point this will be maxima or minima. So we can go in another diagram like in this way. This is x, this is y, this is 0. So if we will take any curve in this way, here we will taking this the maximum values. This is the point, any point x on x-axis. This is fx. The tangent is fx, first derivative of x. So here for maximum value we can write down. Here we are taking a point x minus h. So we will consider here it will be then f x minus h, and its tangent will be f first derivative of x minus h. So here we can look this that for h, if it goes upward, we are taking not maximum at this point. If it goes upward, for a maximum case when the curve arising upward or going to a maximum value, it is going a maximum value, then you can look this that here we are taking another point x plus h. This will be fx plus h, and then tangent will be in this way. Tangent will be f slash x plus h. So here we will get in this way f slash x minus f slash x minus h. The tangent, if we find out, in this curve, since this is upwarding, so at this point we will create another diagram like this. Here I am drawing another diagram for a clear understanding. This is x-axis and this is y-axis. This is point 0. So here we are taking curve in this way when it is getting maximum. So here we are taking 2 points, any point x, here to taking x minus h, here we are taking x plus h. So this is fx, this is fx minus h, and this is fx plus h. Now if we follow these tangents, the tangent will be in this way. It will touch the x-axis here. Its tangent will be in this way. It will touch here at the a point x, and here the tangent will touch in this way. So we have 3 points, point A, B and C. So for point A we have the tendency is maximum, and for this point C the tangent is minimum, and here it is mid value of these 2 tangents at the point B. So tangent at A is equal to f slash x minus h. It is maximum. Tangent at B, it will be f slash x, and tangent at C will be f slash x plus h. So if we can very easily look this, that here the tangent, this tangent is lower maximum. So here f slash x minus h f slash x minus f slash x8 is less than 0, since it is less value than this value, and f slash x plus h minus f slash x less than 0, it is also more or less than this. So here we can look this that we take limits, limit h tends to 0, f slash, if we replace here x plus h for x, if we replace here x by x plus h, we will get the same of this. So for h becomes 0 positive or 0 negative for both, 0 negative for both, f slash x plus h minus f slash x by h is tending to 0. So here this will be less than 0, we are getting less than 0. So here we can take the second derivative. So second derivative of x must be less than 0 if the curve is increasing. Here we can look this, the curve is increasing from A to B to C, it is increasing. So for maximum, this must be second derivative must be needed less than 0 for maximum. In the same way, we can find out the secondary derivative for minimums. Here we can look this. Again, you can draw in this way. This is x, this is y, this is 0. So if we take in this way the curve, this is y is equal to fx. So we are taking this point x, this will be fx. Here we are taking point x plus h, this will be fx plus h, and here this curve we are taking downward for minimums. In such a point it will be minimum. So here we are taking this point x minus h, so this will be fx minus h. Again we are taking point P, Q, R. Here here again the tangent touches the x-axis at the point R, and this tangent touches the point R. This tangent touches the point x-axis in this way, and this point touches the x-axis in this way. So here the tangent at the point R is maximum. Tangent at R is equal to f slash x plus h. This is maximum, and tangent at point Q will be f slash x, and tangent at point P will be f slash x minus h. So maximum value is at the point tangent at the point r. So you can write on here f slash x plus h minus f slash x greater than 0 and f slash x minus f slash x minus h greater than 0. Again we replace here x by x minus x plus h, then we will get the same form. So for points x, if we take limiting value here, where h tends to 0 plus or minus 0 minus, we will get f slash x plus h by f slash x by h. This will be greater than 0. So here h is negative or positive, we will get this greater than 0, or second derivative of fx must be greater than 0 for minimum values. So for minima, the second derivative must be equal to 0. So in this way we can explain the maxima minima. So if you like these videos, then like, share with your friends, and if you have not subscribed, then subscribe this channel.